Hello and welcome back to an Orbiter 2016 video series. This is Tex and this is part 4 of our flight from the Earth to Mars in the XR2. So in the previous parts, of course, we planned the flight, we got off the ground, and we conducted the injection burn. So we're now on our way to Mars. We're still here right by the Earth, but the Earth is soon to be in our rear view mirror, so to speak. So with that said, I'm just going to time accelerate for a moment and let's just enjoy the views. Alright, I always enjoy that view of watching the Earth coast off into the distance there as we head out to another planet. So I'm going to, let me just kill rotation for a moment, and let's take a look at what we've got over here on the Interplanetary MFD on the left side. So you can see, of course, right in the center here would be the Sun, and here is Mercury's orbit around the Sun, and Venus's orbit, Earth's orbit, and Mars, our target, which is indicated in orange. If I center on us and zoom in, you can see that here's the Earth, so we're leaving the Earth behind, and here's the Earth's gravitational sphere of influence, if you will, and here's the Moon. But what's going to happen is when we did that injection burn, we've increased our apoapsis and essentially recenter on the Sun. What that's done is that's increased our orbit altitude out to Mars up here. So we're going to coast out this direction, and Mars is currently right here and we're here, so we will coast out towards the altitude of Mars orbit. We're actually going to go a little past Mars orbit here, and Mars will begin to approach from behind us as we come back down and intercept Mars over here. Our periapsis is still well below the surface of Mars, and with the way we did the burn, it should pretty much stay that way. So we're just going to have to do a course correction once we get pretty close to Mars, just so that we don't hit the center of Mars. So at this point, let me open Orbit MFD over here, and you'll notice that the G-field contribution for the Earth here is beginning to decrease. So when I time accelerate, we'll see that it will eventually drop under 50 and it'll turn red, which means Earth is no longer the dominant gravity field as we continue to coast away. So we're at 1,000 times acceleration. I'll go one more click up. Let me just kill this rotation again. As we get away from the Earth, the kill rotation will work a little bit better. There goes the Moon right there. And again, you see here it's now red, so we are just about out of the Earth's sphere of influence, and we're pretty much out of it now. So we're at maximum time acceleration. Alright, we can change the reference. We'll just hit auto reference and set it to the Sun. Pretty cool, you can see the Moon there and orbiting around the Earth. Alright, so taking a look over here, you'll notice as we begin to drift out here, what I'm going to do is get, roughly around here. It really doesn't matter. I just want to get some distance into our flight plan here. I guess halfway would be, if we intercept Mars here, halfway would be somewhere about here. So anywhere in this range, I just want to stop the time acceleration, and let's take a measure of our remaining delta velocity so that we can input that into our flight log and account for how much delta velocity we have gained from LOX consumption. Because as our crew consumes oxygen, the overall mass of the ship is going to decrease, which with the ship having less mass means we'll have a little bit more delta velocity to work with. I'll center on us again, zoom in. So you can see Mars is kind of over here to the right side and it's closing. Alright, let's take a look at how many days in the flight we are. Alright, so we're at 108 days. It's probably a good time to go ahead and take a measure of our LOX consumption. So let's go over to burn time MFD. Let's put in the extra from the RCS, which is 243.8. And let's open our spreadsheet. So at 100 days, we have a total of 2,211 kilometers per second in delta velocity remaining. So we've gained about 126 meters per second in delta velocity. We're not going to do this mid-course correction burn. We'll just put in 100 days there, and delta V remains the same as above. Okay, and then so let's go ahead and coast out to our first mid-course correction, which will be much closer to Mars. And we'll put input data there just before we do the course correction, and then one more as we're pretty much encountering Mars. Let's see. We need to go ahead and do our fuel too. So what do we, let's see, take a look. So we have 1738.6 in the main tank. I guess this pretty much should be the same. So 1982.4, because we didn't really use anything. Yeah, it's the same. Okay. All right. This would be the same. Okay. Let me get back into the cockpit. And we'll continue to time accelerate. Let's go back to orbit. Okay, we're time accelerating. Oh man, something's going wrong here. Hold on a second. That did not sound good at all. Let's slow time down. Let me turn that alarm off. Alright, let's take a look what's going on here. I don't know if we have that sounded like an explosion or something. Alright, we need to get someone outside and take a look at the vessel, make sure something didn't hit us. Alright, let's evacuate the chamber. We need to open the nose cone, and as soon as the chamber air is evacuated, we can open the outer door. Let's get someone out there. We're going to do a little spacewalk out here in the solar system. That might be a bit scary. Alright, so chamber is almost evacuated. Nose cone is open. Okay, open the outer door. Okay, outer door is open. Let's turn the APU off. We'll EVA.
Egress successful.
Alright, and let's go outside. There he is. Let's switch to our guy.
Translation.
Alright, let's get up here and take a look at the vessel, figure out what's going on.
Rotation. Translation. Rotation. Translation.
There he goes. Take a look here. Oh, there he goes right up there. Hop outside. Very cool. Out here in the sort of middle of the solar system, if you will, doing a little spacewalk. That would be, I think that'd be pretty scary. Alright, let's check it out. Just make sure there's no damage on the vessel here. Let me switch back over to him so we can control him. Alright. I don't see anything obvious. No, it doesn't appear any air or anything is leaking out. Whatever it was, it must have self-sealed. It could have been a meteorite or something hitting the vessel. Let me see if I can rotate the XR2 a little bit to the right, get some more light on it. Let's do a little bump there. Just careful not to hit our guy here. So far, so good. How much space do we have? Oh, plenty of space. We'll just keep the XR2 rotating around so we can assess the damage here.
Rotation translation.
Sort of just have him float here for a second. Make sure the wing's not fixing to hit him. Nope, he's clear. Close this for a minute. Okay, the port side of the vessel looks fine. Don't see any holes or anything in there. No gases leaking. Let's make sure our underside of the vessel, the heat shield, is intact. Don't know what that was, and maybe that was an explosive venting, but whatever it is, we don't appear to have any locks or fuel leaking. So that's a good sign. If our heat shield's in good shape, then we should be able to call it a day. Don't see anything obvious there. Yeah, that's okay. Let me just time accelerate a little bit. Okay, the heat shield underside looks fine. So far, it looks like the starboard side of the vessel here is in good shape. Rudders, ailerons, wings, leading edges, everything looks fine. Radiator looks fine. I think we're safe, so we can go ahead and kill this rotation. Now let's get our guy back inside. We don't want to cook him with too much radiation out here. Oh, I need to select the XR2. Kill rotation. Alright. Let's get our guy back inside here.
Rotation.
Spin him around. Alright, let's get moving over there. Get over there to that docking port. Time accelerate a little bit. See if we can figure out where Mars is while we're out here. Just take a peek around. There's Uranus and Neptune over there. Oh, there's Mars right up there. Still pretty far away. Just a little red dot in space there. All right.
Rotation translation.
Direction.
Rotation.
That's got to be quite an experience doing a tetherless spacewalk out here. Okay. So if we can't get him right inside there. Wrong direction. Let's translate up.
Rotation.
It's kind of hard being outside again.
Translation.
There was a bug with Dan's universal MMU, so we can't really get inside his helmet, so to speak. So we have to sort of just stay outside, and we can still utilize him. Oh, little clipping there. Sorry about that. All right, I think we can hit E. All right, he has gotten back in. Let's get in the cockpit. All right, let's start closing everything back up. Outer door, nose cone. Accelerate. Repressurize the chamber. Okay, so we're good. All right, so let's continue with our coasting. Everything is fine, so we're going to continue with our trip here to Mars. Let's time accelerate. So here we are, and Mars is back here. So Mars is kind of coming up behind us at the moment. I'll go ahead and reference Mars on the orbit MFD. That way we can monitor the G-field contribution as we start getting closer to Mars. We're still a ways away, but we want to be monitoring this because things will happen very quickly when this starts to bump to 0.01. When you're time accelerated here at maximum speed, it's real easy to just fly right into the planet in our case, because we're literally going to hit the planet at the moment. You can see our periapsis is still well below the surface of Mars. Alright, so we've reached the altitude of Mars orbit. Now we're sort of going a little bit higher here, which of course means we're going to be orbiting the Sun a little bit slower than Mars, which will allow Mars to catch up from us. It's currently right behind us.
Warning, oxygen low.
Okay, we're getting another alarm here. Let's get back into our cockpit and check it out. Low oxygen, so 42 days, 15 hours of LOX remaining. We should be good. We're at just about 200 days into the flight. It's not quite time to do our course correction, so let's continue time accelerating here. So I'm going to monitor the periapsis here, and when it seems like it's pretty much stabilized, which it's just about there actually. So right about now, it's not really changing very much. So that means we're getting a pretty accurate prediction for our true periapsis altitude. So obviously right now it's well below the surface of Mars, so if we do nothing we're going to hit Mars. We need to go ahead and raise it above the surface, around 20 kilometers. It's going to change a little bit between now and our encounter, but we'll go ahead and set it at 20K for now. So before we do that, let's input our data into our spreadsheet. So let's see, we're at 214 days, I believe it was. So let's go ahead and put here 214. 214. Yep, okay, and let's check our delta velocity here. External is 243.7 in the RCS tank. And let's go back to, let's also, we used a little bit of fuel, not much, rotating the vessel. We'll go ahead and calculate that. 1738.6 in the main plus 243.7 in the RCS. So that's 1982.3 fuel remaining. So 1982.3. And that's before the, yeah, that's before the course correction. So we'll have to input after. Okay, so delta velocity remaining right now is 2,350 kilometers per second. So we've gained another 139 meters per second in delta V. Now we need to go ahead and do the course correction, and then we'll calculate the delta V after that. So what I'm going to do for this is just use translation thrusters. Let's go to translation, linear RCS, and we'll go over here so you can see it a little bit better. So I'm sort of just going to play with it until I get periapsis here to drop down. And also I want to get relative inclination. I want to make sure that we're not coming into a retrograde orbit. So anywhere between 0 and 90 would be acceptable for a prograde orbit. 90 would be a polar orbit, and above 90 degrees would be retrograde. So we want to come in prograde. And I'm not so much going to concern myself yet about aligning ourselves with the base. We just want to make sure we're coming in on the right side of the planet. And we are currently right now, so we'll monitor that as we do as we adjust our linear RCS here. So let's go ahead and try translating forward. Okay, that's dropping periapsis and relative, or our inclination here, but it's not dropping it very fast, so let's try something else. Okay, now translating up raised it, but if we translate down, okay, translating down is decreasing the periapsis, but it's increasing relative inclination. So we're just going to try a combination. Okay, translating to the right is working pretty well. It's decreasing our inclination and our periapsis, so let's go with that. Just about there. Whoop, I passed it. Okay, that's fine for now. So currently our periapsis is about 19 kilometers above the surface, and our inclination is around 27 degrees, so we're very much prograde orbit, so that looks good. So let's calculate our fuel mass now and our delta V. So we have 241.3 in the RCS tank. Let's do our fuel mass. Main is the same, 1738.6 plus 241.3. All right, so 1979.9 after in kilograms of fuel after our first course correction. So it only took 2.4 kilograms of fuel, and our delta velocity remaining is 2348. So it took a whole 2 meters per second in delta velocity for that course correction, and I think I estimated around 20. Yeah, I did. So okay, so let's see, actual flight, what did we do? We did, I forgot to put that in, we were at 100 days, and our actual APU fuel remaining was 244.1 at the time, and we used 0 delta velocity. What was our delta V remaining at that point? It was 2211. Okay. And then we did the first course correction at 214 days. So we actually did it at 214. The actual APU fuel remaining is 240.9. We used a little bit that I didn't account for when we had that sudden explosion, so we had to investigate that. So we used a little bit of APU fuel, not too big of a deal. And again, the ended up taking 2 meters per second in delta V, and so the actual delta V remaining after 214 days is 2348. Alright, and so we just need to coast to our final course correction just before encounter. So that all looks good. Flight log set. Okay, so let's continue coasting a little bit closer to Mars. We'll get back in the glass cockpit. Make sure we have orbit open. Alright, let's tell you what. Let me also open. Let's go to Interplanetary on this side. Let's go ahead and get our base approach set up. Okay, so we want to share with this side. And then we want to go base approach. We want to reference Mars. We want to target Olympus. Okay. And we want our altitude to be at 20K. And we also want to do orbit insert. Okay. Now we'll monitor that as we get closer. And let me open up an external MFD for the orbit. Okay, that'll work. We'll just stick this right here in the center, and I'm going to be watching the G-field contribution there. Alright, so let me very carefully time accelerate. Things are going to happen pretty quickly because we're getting relatively close here to Mars. Let's watch for the first little change here in the G-field contribution. Okay, there it is. Notice our periapsis is up to 30 kilometers, just over 30 above the surface. Not a problem. Alright, so now I'm looking over here, and this number right here, delta velocity it's giving me, is telling me currently we're at 4.5 meters per second in delta velocity required in order to get in line with Olympus base and also have our periapsis altitude at 20 kilometers. That's not very much at this point in time, so let's just get a little bit closer and get things a little bit, our predictions will be a little bit more accurate. But we don't want to let this climb too high. It's already above 5. So if it continues to climb like it is, we should probably go ahead and yeah, let's go ahead and do that course correction now, because the closer we get to Mars, it's going to cost more fuel to do that. Alright, let's see. What we can do is we can also do this by translating, but you can also hit page and look at your burn vector to do it. So I'll go ahead and do the burn vector just to do something different, but before I do that, we need to once again hop over here and check our fuel pre-course correction. So external is the same. Alright, so let's go to the spreadsheet. So we're at 234 days now. So our final course correction is at 234 days. Delta V remaining is 2375. Fuel remaining is the same, 1979.9. Okay, and then after the course correction, which we're fixing to do, is 234 days. So we'll input that in just a moment. All right.
Rotation.
We'll need rotation RCS. Let's go to the orbit HUD. And let's go back to Interplanetary. Okay, so I'm going to just rotate up and to the right a little bit. We're going to bring that plus right into the center of the target. We could auto burn it, but it's such a low delta V. I'll probably just do it myself. It's probably easier to auto burn, but you know, hey, why not? I think just use translation thrusters or just a little tick of the main engines since we're orienting the vessel here. I think it might use a little bit less fuel if I do it myself as well, especially when it comes to orienting the vessel here. Okay, let's just try a little bit of main engines. There we go. We'll clean it up with translation here in just a minute. Okay, let's finish it off with
Translation.
linear RCS. Translate up to the left. Bring that plus in the center again. And forward. Oops. Okay, that's on 0. Alright, let's kill rotation. Now hopefully that is the last course correction we'll have to do. And I should go here first. Burn time. 239 in RCS. And let's do our fuel real quick. So we have 1733.5 in the main tank plus 239 in the RCS. So spreadsheet. Alright, so fuel is 1972.5 after the course correction. And delta V is 2367. So it took 8 meters per second for that one. Again, that was at 234 days. So actual flight was 234 days. Actual APU fuel remaining is the same. It's 240.9. And again, that took 8 meters per second in delta velocity. So we're under target. That's great. 2367 remaining. Alright, so we've got all of our data entered. Now we just have the encounter. It's probably where we're going to have to end this video. We're right on 30 minutes, just over. So let me tell you what, let's go ahead and rotate around so we're sort of facing Mars. Okay, we're going to rotate
Rotation.
prograde. Let me just time accelerate. There should be Mars right there in front of us. Yeah, there it is. Sort of on the night side, so you can't see it very well. Alright, let's go back over here to Interplanetary. Turn off burn vectors. Alright, let's time accelerate. We'll get within 50 on the G-field contribution. And that's well within the encounter, so probably where we'll go ahead and end this part. So let's time accelerate. It's cool, you can see Phobos and Deimos there, orbiting Mars. So it's interesting, I set this base approach up. I wonder if it's because I'm too far out from Mars, even though I selected Mars as the reference, targeted Olympus. We brought the delta velocity to 0, but I just noticed the periapsis over here is below the surface. So that is sort of interesting. You can also see it here. Let me hop over into the... You can see that our actual flight is below the surface, but what I wanted, what I set it at 20K, the blue line here, is right where it should be. So that's new for me. I'm not sure why that's happening, and I'm wondering if I should trust the periapsis here versus this one here on the base approach, because this periapsis on the map program is generally very accurate, especially when we're this close to the planet. So what I'm thinking is that we should trust this, and that means we're below the surface of Mars. That's not good. All right, so I think I'm going to do that. Let me do that real quick. We'll update our numbers, and that's where I'll have to end this video. All right, so let's go to
Translation.
okay, sorry, translation. And let's just try translating. Let's see which way. I guess it would be down. There we go. So I'm just going to bring our periapsis over there on the map program on the left side down, bring it up to 20K above the surface. And yeah, look over here. That's interesting. Now the delta V is actually closer to 0. It is decreasing. I wonder if I did that a little too early. Maybe Dimitri or David can shed some light on that. I know that especially Dimitri is definitely an expert with this program. I'm sort of just learning it, so yeah, you'll have to bear with me. Again, this isn't a tutorial. We're sort of just learning as we go along here. But let's go ahead and set the periapsis to 20K. I think I'm going to trust that better. So we're using a little bit more fuel for the course correction, but really not too much. Since we're still a little ways out from Mars, it's not as expensive as if we had waited until we were much closer. Alright, so there's periapsis at 20K, so that will suffice. Alright, let me go back, and now DV is right on pretty much right on 0, so I'm not sure what happened there. I'm sure I screwed something up as usual. Let me just update our numbers to account for the extra fuel we just used, so 236 on RCS. Alright, so we're 1 day past that correction burn. Rather than just putting in a separate line, I'm just gonna update this to the course correction burn here is 235 days. So the actual delta V remaining now is 2366. So it took another meter per second in delta V. Yeah, that'll suffice. Okay, and then fuel really isn't going to be much, but 1733.5 is the same, and 236 in RCS. Okay, so the actual fuel used, or the actual fuel remaining, is now 1969.5. Okay. Alright, let me save that. And once again, let me go to orbit over here, and let's continue coasting a little bit closer to the planet. We'll get within 50 of the G-field contribution here. It's going to happen pretty quickly. There we go. Alright. Alright, so this is where I'm going to leave this video off. We're pretty much here at Mars. So the next video, we're going to have the excitement of an aero capture maneuver. And we need to consider about landing at Olympus Base. Thank you guys for watching. I really appreciate it. It's been fun, and we will see you in the next video.